the words of John Kartaltepe from the Rochester Institute of Technology in New York, we had an idea of what galaxies would look like at these distances and how much detail we could see, but I think the reality far exceeds our imagination and really blows us away. Imagine gazing into the cosmic nursery and witnessing the presence of something that defies the very laws of existence. The James Webb Telescope, our cosmic sentinel, has made a revelation that shatters the foundations of modern theories. As we stand at the precipice of a new scientific era, the path before us is shrouded in mystery. None can predict the destination of this extraordinary journey, but one thing remains unequivocally clear. The latest findings are nothing short of groundbreaking, utterly staggering, and they will irrevocably reshape our comprehension of the boundless universe. Welcome to Universal Narratives, where we unveil the mysteries of the cosmos. The James Webb Space Telescope, or JWST, a technological marvel worth $5 billion, surpassing the Hubble telescope in image range and clarity. Since 2022, this telescope has provided us with stunning images of the primordial universe, distant cosmic nebulae, menacing black holes, and planets within our solar system. With its 16 honeycomb-shaped mirrors and unique infrared technology, it stands as humanity's most extraordinary telescope. Thousands of astronomers on Earth placed their hopes on the JWST, eagerly awaiting its launch, knowing that its new capabilities would reveal what they had dreamed of their entire lives. They sought the truth and confirmation of ideas that had remained mere theories on paper, but then came the shock. The JWST performed admirably after being safely positioned in space. It pointed its mirrors at a seemingly empty region of the cosmos for over 72 hours. However, what appears empty to us when we gaze at the sky from Earth is precisely where the James Webb captures the oldest light signals of the universe, with no nearby stars or galaxies to interfere. In the foreground, the telescope can collect light signals traveling to us from 13.5 billion years ago or even more. After extremely long exposure times, these ancient signals appear as blurred red dots. The orange light is a bit closer to us, the yellow even more so, and the distinctly recognizable spots of blue or white light come from closer light sources. The vast majority of the light signals in this image do not originate from individual stars. We mainly see the light from very ancient galaxies. These galaxies challenge science. Surprisingly, many scientists were not as thrilled as expected. The results did not align with their desires. Astronomers and cosmologists immediately began analyzing this image. It was clear that this image would reveal the oldest galaxies in the universe. But no one knew just how ancient they were, how they formed, how dense they were, and what elements they contained. The shock was significant when Indo-American researcher Jeyhan discovered a galaxy that existed 300 million years after the Big Bang, and this would not be the only discovery of its kind. Naidu and his team, along with other international research groups, discovered one very ancient galaxy after another. Reports overflowed, and it soon became evident that something was amiss with the Big Bang theory and the previous cosmological perspective. Galaxies like these existed in a time when there should have been only star prototypes. Who will find the answers to all these new questions? The magic of this discovery is that many dedicated young researchers felt encouraged to think differently, to continue searching for even older galaxies, and to believe in the possibilities that conservative research had long rejected. New theories are being proposed, and old models of the universe that never received the attention they deserved are making a comeback. Our cosmos is undergoing a scientific re-education, so to speak. Therefore, the JWST only disappointed those who hoped that everything would remain unchanged. Those who believed that the Big Bang theory was not entirely compatible with the realization of modern quantum physics. The new discoveries confirm that we continue to seek the truth about the origin and nature of our universe and do not rely solely on theories. In fact, this evolution was predictable. One of Hubble's most recent major discoveries was the GNZ11 galaxy, existing with a redshift of 11.6, approximately 420 million years after the Big Bang. This discovery puzzled some who tried to reconcile it with old concepts, but it was just a singular case that needed an explanation. The higher the redshift, the further back in time we observe a galaxy. Redshift describes how much a galaxy's light has been stretched as the universe expanded. The galaxies first discovered by Rohan Naidu and his team had a redshift of 13, meaning they existed around 300 million years after the Big Bang. Subsequently, the discovery of galaxies with redshifts up to 20 was announced. Conservative scientists have so far defended against these numbers, claiming that all these discoveries are highly uncertain, as none of these redshifts have been confirmed yet. Furthermore, it has not been proven that these are actual galaxies. However, the undeniable presence of light signals, even if very ancient, raises the question of their origin, if not from galaxies. Determining the age of galaxies is challenging. A common method to detect and determine very ancient objects in space is gravitational lensing. Astronomers led by Jeyhan from the University of Missouri and Columbia used it to find 88 candidate galaxies beyond a redshift of 11. Jeyhan's team also found a galaxy with an incredible redshift rating of 20. These galaxies would be the most distant ever discovered if confirmed. High redshift galaxies have been found in 2 other studies where the JWST used deep exposures without gravitational lensing. These images are part of the JWST's Cosmic Evolution Early Release Science, SEERS study. SEERS worked with evaluations from the JWST's near-infrared camera, as well as findings from the JWST's near-spec camera. Additional information about the alleged universes has been determined using the JWST's near-infrared spectrometer, or NIRSpec. Using other instruments like the mid-infrared instrument or the MIR camera, astronomers at the University of Edinburgh used a similar approach to discover another candidate galaxy with a redshift of 16.7, meaning this galaxy existed only 250 million years after the Big Bang. A team led by doctoral student Callum Donan discovered 5 more galaxies with redshifts above 12. Another team led by Stephen Felstein from the University of Texas at Austin used the SEERS method to discover a galaxy with a redshift of 14.3, placing it 280 million years after the Big Bang. This galaxy became known as the Macy Galaxy, and Felstein promptly turned the discovery into a birthday gift for his daughter Macy. These galaxies have not been confirmed yet, as our current technology cannot definitively prove they are galaxies. Computers work with the light spectrum and analyze it. The computer assumes the light was emitted by galaxies, thus determining reasonably accurate values for size, density, mass, the number of stars, and more. However, this does not prove that this light was indeed emitted by galaxies. There is also discussion of ultra-supermassive black holes, which can shine brightly under certain circumstances. If the computer assumes the light was emitted by black holes, the results change. The current technology's weaknesses lie in establishing what we are actually observing. Even if the light was emitted by black holes, we must wonder how such gigantic black holes could have existed shortly after the Big Bang. These distant galaxies show evidence of significant ultraviolet light emissions, providing further proof of hydrogen gas ionization, which, according to previous cosmological models, should have ended the cosmic dark ages. During the dark ages, there was no light in the young universe. Only when the first stars began to shine did the universe light up. In their article, the Edinburgh team calculated the ultraviolet brightness of candidate galaxies between redshifts 8 and 15. The amount of ultraviolet light emitted by these galaxies at a given time was averaged using the previously mentioned measurement techniques. Galaxies typically emit more ultraviolet light than young hot stars. Donan's team concluded that there was indeed more than enough ultraviolet radiation emitted by stars in these primordial galaxies to ionize the universe. This means that these new high redshift galaxies might well have existed near the beginning of the universe's illumination. Unlike modern galaxies that can host hundreds of billions of stars, these galaxies were likely only a few thousand light-years in diameter and contained only tens of millions of stars, according to the Scottish experts. The newly discovered galaxies reflect the generations of galaxies that formed shortly after the first and are still in their infancy. The abundance of high redshift galaxies discovered by the JWST, along with the quantity of ultraviolet light shifted to longer infrared wavelengths, further suggests that galaxies were more numerous in the early history of the universe than previously thought. This would be an entirely new discovery, but would not necessarily overturn the Big Bang theory. We would simply need to adjust our previous assumptions about the duration of the Dark Ages and the formation of the first stars and galaxies. According to F.R.L. Stein's team, our cosmos was already shining brightly with many small galaxies less than 300 million years after the Big Bang. However, it's essential to note that they are not the only ones searching. Other researchers have found very ancient galaxies in JWST images that appear much larger and more massive. Their brightness could correspond to that of modern galaxies. These researchers conclude that the first galaxies, if they were the first galaxies, must have been true star factories. It is believed that many very bright and short-lived giant stars were formed. The existence of these early giant stars was an unverified theory until now, and there is evidence that could confirm this idea. The discovery of ancient galaxies of varying sizes and brightness challenges previous assumptions. In summary, the James Webb Space Telescope, with its remarkable ability to detect high redshift galaxies, has opened a new chapter in the observation of the primordial universe. These astonishing discoveries raise new questions and challenge established theories, urging scientists to reconsider and revise our understanding of the origin and evolution of the universe. While the discoveries may initially seem startling, they represent significant progress in scientific research and encourage scientists to think differently and continually seek the hidden truths within the vastness of the universe.